Good day, students. How are you? Our topic is named the probability that the continuous random variable with the normal distributive density will fall into the given interval by means of the error integral. Now write this topic, the name of this topic, the probability that the continuous random variable with the normal distributive density will fall into the given interval by means of the error integral. Now I will translate for you in Azeri and in Russian. The probability that the continuous random variable with a normal distributive density will fall into the given interval by means of the error integral. In Azeri, it means səhvlər integralının vasitəsilə verilmiş aralığa deməli normal paylama sıxlığı normal olan kəsilməz təsadüfi kəmiyyətin verilmiş aralığa düşməsi ehtimalının deməli səhvlər integralının vasitəsilə ifadə edilməsi. In Russian, вероятность, что непрерывно случайная величина с нормальной плотностью распределения попадет в данный интервал посредством интеграла ошибок. Remember that the probability of falling of the continuous random variable into the given interval alpha beta is defined by the following interval p capital of that the continuous random variable will situate between alpha and beta is equal to the definite integral from alpha to beta f of x dx. Here f of x is normal distributive density and its expression is following f of x is 1 over sigma square root of 2 pi multiplied by e to minus x minus a squared over 2 sigma squared. It is normal distributive density. Then substitute expression of normal distributive density instead of f of x in the integrand. Integrand, it is in Azeri it is integral altı funksiya, in Russian it is podintegralная funksiya. Then rewrite p of alpha is less than x is less than beta is equal to integral from alpha to beta of 1 over sigma square root of 2 pi multiplied by e to minus x minus a squared over 2 sigma squared dx. Continue. Here 1 over sigma square root of 2 pi is a constant factor, and we can take it out of the integral symbol. And x minus a squared over 2 sigma squared we can rewrite in the following form, in the form of x minus a over sigma square root of 2 squared equals 1 over sigma square root of 2 pi multiplied by integral from alpha to beta of e to minus x minus a over sigma square root of 2 squared dx. Then make the following change x minus a over sigma square root of 2 by t, by new variable t. Now write change x minus a over sigma square root of 2 is equal to t. Then find from here x and then dx, and then also change the integral limits. X is equal to a plus sigma square root of 2t. Then dx is sigma square root of 2 dt. Then we must change also the integral limits, because these integral limits alpha and beta are given for x, for the integral variable x. But we must find the integral limits for the new variable t. If x is alpha, let x alpha, then substitute alpha instead of x in this expression, and then we will obtain t is equal to alpha minus a over sigma square root of 2. But if x is beta, x equals beta, then t is equal to substitute beta instead of x, beta minus a over sigma square root of 2. Then apply this change to this integral. Continue. Equals 1 over sigma square root of 2 pi multiplied by integral. We must change alpha by alpha minus a over sigma square root of 2, and change beta by beta minus a over sigma square root of 2. Integral from alpha minus a over sigma square root of 2 to beta minus a over sigma square root of 2, and of e to minus t squared, and dt is equal to sigma square root of 2 sigma square root of 2 to dt. Then continue. Sigma square root of 2 is the constant factor which can be taken out of the integral symbol. Then we have sigma square root of 2 over sigma square root of 2 pi multiplied by integral from alpha minus a over sigma square root of 2 to beta minus a over sigma square root of 2 of e to minus t squared dt equals. here we can simplify the fractional coefficient of integral by sigma square root of 2. And find here we have 1 over square root of pi, multiplied by integral from alpha minus a over sigma square root of 2 to beta minus a over sigma square root of 2 of e2 minus t squared dt. Then separate this interval into two intervals. First interval will be will be integrated from alpha minus a over sigma square root of 2 to 0, and second interval from 0 to beta minus a sigma square root of 2. Rewrite this integral 1 over square root of pi, first integral from alpha minus a over sigma square root of 2 to 0 of e2 minus t squared dt, plus integral from 0 to beta minus a over sigma square root of 2 of e2 minus t squared dt. Then change the places of the first integral, and in this case the first integral will change on sign. We will have a negative sign in front of the first integral. Continue. 1 over square root of pi multiplied by minus integral from 0 to alpha minus a over sigma square root of 2 of e2 minus t squared dt, plus integral from 0 to beta minus a over sigma square root of 2 of e2 minus t squared dt is equal to. Then change the places of these integrals. 1 over square root of pi multiplied by integral from 0 to beta minus a over sigma square root of 2 of e2 minus t squared dt, minus integral from 0 to alpha minus a over sigma square root of 2 of e2 minus t squared dt. And continue. Now use the error integral, and therefore remember the expression of error integral. Remember, error integral is denoted as phi capital of x. It is 2 over square root of pi multiplied by integral from 0 to x of e2 minus t squared dt. For this multiply and divide the coefficient, by 2 at the same time, and then for this first introduce this coefficient into parentheses and continue. Introduce this coefficient into parentheses. Uh, 1 over square root of pi integral from 0 to beta minus a over sigma square root of 2 of e to minus t squared dt minus 1 over square root of pi multiplied by integral from 0 to alpha minus a over sigma square root of 2 of e to minus t squared dt. Then multiply and divide the both of integrals, by 2 at the same time. Then we'll have 1 second multiplied by 2 over square root of pi multiplied by integral from 0 to beta minus a over sigma square root of 2 e to minus t squared dt minus 2 over square root of pi multiplied by integral from 0 to alpha minus a over sigma square root of 2 of e to minus t squared dt. Again, remember the expression of error integral, and this error integral depends on the upper integral limit. Here, upper integral limit is beta minus a over sigma square root of 2, and in the second integral, our upper integral limit is alpha minus a over sigma square root of 2. Therefore, it is 1 second multiplied by phi of beta minus a over sigma square root of 2 minus phi of alpha minus a over sigma square root of 2. Therefore, already we obtained the expressing the probability that the continuous random variable with normal distributive density will fall into the given interval alpha beta is by means of with help of the error integral. Thus we have p of alpha. It is the probability that the continuous random variable will be situated between alpha and beta, is equal to 1 second multiplied by phi of beta minus a over sigma square root of 2 minus phi capital of alpha minus a over sigma square root of 2. Then go to the next topic. Next topic is named the cumulative or integral distributive function of normal distribution, its properties and its graph. First, find the expression for the cumulative distributive function. The cumulative cumulative or integral distributive law, or function, distributive function, or law for the normal distribution, its properties and graph. In Azeri it is normal paylama üçün integral paylama funksiyası, onun xassələri və qrafiki. In Russian it is интегральная функция распределения или интегральный закон распределения для нормального распределения, его свойства и график. First, obtain the expression for the cumulative distributive function of the normal distribution. Remember formula of general formula of cumulative distributive function. F capital of x is the integral from minus infinity to x, f of x dx. But it is also the probability that the continuous random variable will fall into the interval from minus infinity to x. F of x is equal to p capital for continuous random variable x bar between minus infinity and x. Then remember the expressing this probability by means of error integral. For this, remember also the error integral. That is expression of this probability by means of error integral. P is that x is situated between alpha and beta is equal to the 1 second multiplied by phi capital of beta minus a over sigma square root of 2 and minus phi of alpha minus a over sigma square root of 2. And then use this formula. But here alpha is minus infinity, it is alpha, and beta is x. Then continue. Continue. 1 second of phi of x minus a over sigma square root of 2 minus phi of if substitute minus infinity instead of alpha, we will obtain minus infinity minus a is minus infinity, because if subtract the constant value from minus infinity, then we will have again minus infinity. then minus infinity divided by sigma square root of 2, because sigma square root of 2 is a positive quantity. Minus infinity divided by positive value is also minus infinity. Phi of minus infinity. Then remember that the error integral is odd function, and it means we can take the negative sign out of the error integral symbol. Then we will obtain here plus equals 1 second multiplied by phi of x minus a over sigma square root of 2 plus phi of plus infinity. Then remember that at positive infinity the error integral tends to unit, simply unit. Then we will have this quantity tends to unit. Then finally we will have f of x is equal to 1 second multiplied by phi of x minus a over sigma square root of 2 plus 1. Then consider the properties of this function. It is expression of the cumulative distributive function, for of the normal distribution. Then consider the properties of this function. First, calculate the value of this function at the point A. Properties. First property, f at A, then substitute A instead of x. 1 second multiplied by. If substitute A instead of x, we will obtain A minus A will give 0. 0 over sigma square root is 0. Phi of 0 plus 1. Phi of 0 plus 1. But already you know that the phi of 0 is 0. Then we have 1 second multiplied by 0 plus 1 is equal to 1 second. That is f at point A is 1 second. It is our first result. That is result of the first property. Then investigate the second property and investigate the behavior of this function of the cumulative distributive function at first and at plus infinity. Find limit of this function at plus infinity, at positive infinity. Limit f of x when x tends to plus infinity. Then substitute plus infinity instead of x. Then substitute plus infinity instead of x in this function. If substitute plus infinity instead of x, then we will obtain plus infinity minus a is plus infinity divided by positive value is also plus infinity. 1 second, phi at plus infinity plus 1. But you know that at plus infinity every integral tends to unit. 1 second multiplied by 1 plus 1 it tends to unit. Then we have 1 second multiplied by 2 is unit. That is limit f capital of x when x tends to plus infinity is unit. It is a result of second property. It means the straight line with the equation y equals unit is the horizontal asymptote of the graph of this function. And finally, investigate the behavior of this function f capital of x at negative infinity. That is, find the limit of this function when x tends to minus infinity. Limit f of x when x tends to minus infinity. Substitute minus infinity instead of x, f of minus infinity is equal to, then use this expression 1 second multiplied by phi of, if substitute minus infinity instead of x, minus infinity minus a is minus infinity divided by sigma square root of 2 is minus infinity, also minus infinity. Minus infinity plus 1 is equal to equals 1 second, and already you know that the error integral at minus infinity tends to minus 1. Then we have 1 second multiplied by minus 1 plus 1, it is 0. 1 second multiplied by 0 is 0. That is, our function at minus infinity tends to 0, and it means the line whose equation is y equals 0, that is x axis or abscissa axis is another horizontal asymptote of the function graph, and further construct the graph of this function. Finally, construct the graph of cumulative distributive function according to the properties of this function. Our graph passes through this point, because at the point A our function is equal to 1 second. And it is the graph of function f capital of x is 1 second multiplied by phi capital of x minus a over sigma square root of 2 plus 1. According to the first property, at the point A, our function is equal to 1 second. Really, graph of this function passes through the point with the coordinates a 1 second. A 1 second. Then our function test plus infinity test to the unit, and really the line y is 1 is the horizontal asymptote of our graph. And finally, according to the last third property, at minus infinity our function tends to 0, that is the abscissa axis, whose equation is y equals 0, is another horizontal asymptote. Dear students, our lesson ended. Thank you for your attention and good luck, students.